You can transfer your IRA or old 401k and get a 3% boost.
Hello, all right. I hope you guys had your quick coffee break. Let's get those feet back into the seats here. My next speaker is Patrick Hall. Patrick is a professor of AI risk at the George Washington University. He is an assistant professor in the School of Business. He specializes in data ethics, business analytics, and machine learning. He conducts a lot of research to support the NIST's AI risk management framework and is affiliated with a lot of the fair lending and AI risk management advisory firms. So guess what? He's also a co-founder of a boutique law firm focused on AI governance and risk management. Former H2O kind of guy. He used to lead our efforts in responsible AI. He held various roles at SAS Institute, including customer-facing roles and R&D roles. Let's give it up for Mr. Patrick Hall.
Okay, so if you pay attention, I might save you from reading hundreds of pages of thick government documents. Okay, you should still read them, but I'm going to give you an overview. I'm going to get you through them. I'm going to get you through them quickly, and I look forward to your questions too. Okay, so what we're going to talk about today, and I've heard other speakers bring this up, is what's known as the NIST AI Risk Management Framework. And this is something that Congress asked a government agency within the Department of Commerce, NIST, National Institute of Standards and Technology, to do because we all know that AI is becoming such an important part of our lives. And it has benefits and risk, and we want to make sure that those risks are managed. And I've been a part of the AI risk management framework from the beginning, but it's very important for me to, this is DC, so we all have to disclaim ourselves. One, I am not a NIST employee, I'm not a government employee, I do not speak for NIST. My relationship to this piece of work is that I've been a grantee. I've been doing research through a university to support this effort since its inception, basically. Okay, so I do not speak for the government, I do not speak for NIST. All right, but what is this NIST AI risk management framework? Well, basically it's documents and websites, okay? And in the most fundamental sense, it's documents and websites that your tax dollars pay for, your and my tax dollars pay for, and you can go to these websites and get these documents and read them and really get very solid and crucially objective, independent advice about how to make AI less risky within your organization. So I'm not a big believer that today's AI systems are smart enough to take over the world, but I am a big believer that today's AI systems are smart enough to cause fairly serious problems, and one serious problem that they can cause, problems they can cause relate to threats to our democracy, okay? So AI systems and generative AI systems in particular are very good at generating what boils down to fake news, right? Fake content. They're very good, algorithms, viral algorithms are very good at radicalizing people. And so there are serious issues here for some of our democratic institutions. So an important part of the NIST AI risk management framework is it's meant to be rights preserving. So it's a rights preserving framework. As some other, my very close colleague, Riva brought up earlier, NIST is not a regulator, okay? And the NIST AI RMF is not a regulation. It's voluntary. And you don't have to do every little part of it to adhere with it. The core of it is thinking through risk, being risk aware, making decisions, acknowledging that these technologies have risk, and doing something about it. And that's the flexibly applied part. And then, NIST is all about measurement, right? NIST, they're the atomic clock people. So we work on ways to improve measurement of the benefits and risk of AI systems. And especially with generative AI, these very broad application systems that can, be applied in many different applications, it's hard to measure those things. And as Riva pointed out earlier, we're sort of just getting started in how to measure some aspects of risk and benefits around complex AI systems. The AI risk management framework is not designed for any particular vertical. We seek profiles, so we'll talk about profiles for the NIST AI RMF a little bit later. But the core RMF, the core of what's been done so far, is not targeted at any particular vertical. And we are also proponents of the socio-technical systems approach. And that's a big word that simply means we acknowledge that AI systems are in and of the world. Okay, so AI systems, are created by people, typically to do things for people, and they typically have impacts within our world. And that's how we think of AI systems. We don't think of AI systems as just computers and digital data and sort of locked in that world. We think of how they interact with the world. Okay. All right, so you can read the slides just as good as I can. So here's our definition of an AI system, and we use a very traditional definition of risk. So, all the MRM folks that have been up here, we use the same definition of risk that they do. The likelihood that something bad will happen multiplied by the cost or impact if that bad thing happens. But we want to acknowledge that this isn't all about risk. Of course it's not all about risk. It's also about benefits. So there can be positive outcomes here too, and we would think of the positive outcomes and sort of measuring their impact in that same way. And the picture that you're seeing here, this is the core document of the AI RMF. This is a kind of fairly strategic policy level document. It doesn't talk about data poisoning or adversarial example attacks. That's the playbook, and we'll talk about those in just a second. But this document that you're looking at now, this is sort of the core document that lays out all the other pieces. Okay, so you've all probably seen an AI lifecycle before. I won't torture you, but the interesting thing about the NIST AI lifecycle, in my opinion, is that it places people and the planet in the center. And I think that's really important. Again, getting to this notion that AI is all around us, or machine learning, depending on how you define these things. Machine learning is all around us, and it really does affect people and the planet. And so I think this was a smart thing that NIST did to put people and planet in the middle of their AI lifecycle. And another important thing here is that we define this notion of AI actors, which is just a fancy way of saying people that interact with AI systems, but not all of those people are coders, right? There's a lot of people, say, like attorneys and risk managers, data privacy compliance, any number of other people that don't just code, that interact with AI and machine learning systems. So I think these are some unique things from the NIST perspective on the AI lifecycle. Okay, the core RMF puts forward 7 characteristics for trustworthiness. I think they're fairly obvious, and so safety is a big one these days, right? People have gotten very into AI safety. That's always been sort of a desirable characteristic for an AI system, and it's one that we're very focused on as well. Of course, security, explainability, and interpretability. I'll show a paper in just a minute. There are people in this room that I brought one of the first explainability products to market with, and I think NIST has done great work on explainability and interpretability, and we'll talk about some definitions for those things. But essentially, explainable is low-level kind of technical information that talks about how a system works, whereas interpretability is placing some aspect of the system, data, generated content, a prediction, into its context, into its human meaning context. We want privacy. We want bias managed. We don't go so far as to call any AI systems fair. A very sort of important kind of takeaway from NIST research into AI is that there is no current system today that has zero risk of bias. So all AI systems are biased, but we want to manage that bias. Then we have these sort of, we have accountability and transparency down the side, right? This is a very fundamental aspect of what would make an AI system trustworthy, is if the people around it are accountable for its behavior and that it's transparent in a meaningful way, right? And, you know, I do a lot of work in explainability. By transparent, we don't mean like a vector of Shapley values. That's not what we mean. We mean that the people around the system and the users of the system have some meaningful idea about how it works and what they can do if something goes wrong. And all of this is based on, and this is my favorite part, we really want our systems to be scientifically valid and reliable. And we mean reliable in the traditional sense that a system is supposed to operate within certain parameters for a certain amount of time. And if it moves out of those parameters, then it's not reliable. So we want to take traditional definition, traditional meanings of validity. Is the system scientifically valid? There are AI systems on the market that are certainly not scientifically valid, and we want the systems to be reliable. They're operating to be reliable. And I always like to point this out, right? Computers don't trust. Computers are just computers. They don't trust anything. Only humans can make computers trustworthy. And it's hard work. Okay, so within the core RMF, there's the 7 sort of desirable characteristics for an AI system, and then the 4 functions by which you can achieve these things, okay? So there's the govern function, the map function, that is maybe the most important function, and I think people struggle with it the most, the measure function and the manage function. So by governance, all the smart model risk management people who have been up here before me can tell you all about governance. But what we mean by governance is things like clear lines of command and communication, right? It's very clear whose responsibility is whose, and how you communicate in the instance of some kind of problem, okay? Written policies and procedures so that people know the rules. The rules are written down, the rules are transparent, everyone knows what they should be doing. Documentation is a crucial part of governance and MAP, and I think one of the things that we can do to make documentation easier for practitioners is documentation templates. Supplying templates for practitioners so they don't have to start a big, paper from scratch about every model that they train. And then very, very crucially is incentives, okay? Like I said in the beginning, doing risk management around AI systems is difficult. It's tedious. It can be a lot of work. People aren't just gonna do it for free, okay? People have to be incentivized to do extra work, right? And so we need to, it is part of the governance function to incentivize practitioners and other AI actors within organizations to actually engage in risk management. People should be incentivized to do risk management. It's unrealistic to think that people are going to do risk management for free. Okay, so that's govern. Map. Map means essentially you put your risk on the map. You put your benefits on the map. You document them, and in that documentation process, you prove to yourself and to the management and to your regulators, whoever it is, you prove to yourself that you understand the risk and benefits, okay? And, I'm fancy, so I like to use this term in vivo, within the living. We want, the risk isn't that your AUC is low. I mean, that's a risk. That's a minor risk. The risk is that someone is hurt in the world, or that money is lost, or that value is lost, okay? The risks are in vivo. The risks are in the world. The risks aren't on the computer. The risks are in the world. So we document those risks, and we understand them, and we write them down. Okay. Measure, measure can be measuring the AUC or whatever people like to measure about generative AI models. But as I said, we really want to focus on measuring impacts in the world, and that's more difficult, right? That takes structured experiments. That takes actual, applying the scientific method, structuring experiments, and trying to measure the impact of systems in the world. some things we just don't know how to measure yet. So we need to kind of track those and document those. And if we are, I think if we're honest with ourselves, we really can't measure everything automatically with AI. It's just going to take some human involvement. It's just going to take rolling up our sleeves and thinking about things and trying to track, document, and measure them, even if we don't have statistics for them yet. Okay? So we need feedback from our users, right? And H2O is very into feedback from their users. I can promise you that. And that's why they keep developing products, is because they take feedback from their users. So if you want to build a good AI system, you need to build in the ability to take feedback from your users, because you can measure whatever you want. You can measure AUC or F1 or all the different statistics. That doesn't mean that your users are going to have the experience that you want them to have. And there's many different ways to think about this. Your users may be having positive experiences that you don't even know about. Okay? They could certainly be having negative experiences that you don't even know about. So we really need to engage in what we call structured human feedback, being serious and systematic about getting user feedback. Okay? That's a huge part of measuring how AI systems work, and it's a core part of the AI RMF. Okay. And risk management is when we do something, okay? We've set up governance structures, we've documented our risk, we've understood them, we know how to measure some of them. The ones that we don't know how to measure, we're gonna be trying to get user feedback, we're gonna be monitoring them by more manual methods, then we're gonna manage the risk, we're gonna implement these things. Key parts of this are risk prioritization, okay? Risk tiering, risk levels. No organization, not the biggest banks, not the US government, not the biggest tech companies have all the resources that it would take to manage all of their risk. Okay, we apply a risk-based standard. High-risk systems that are likely to fail, or when they fail they have a large impact, they get the most attention. If you don't apply a risk-based standard, you will spend all your resources potentially on low-risk systems, and that's not good risk management. And then risk mitigate, what do we do? Well, we can mitigate risk, we can apply controls, we can do things like bias testing and bias remediation, or potentially one day we'll be able to transfer risk, right? You'll know that AI has reached a serious level of maturity when you can buy an AI insurance policy, right? And some of the biggest insurance companies in the world are piloting programs on AI insurance policies. And they typically sort of grow out of the cyber insurance division of insurance companies. So you'll know that AI has reached a very high level of maturity when you can buy an insurance policy, right? And that's risk transfer. And then we can accept risk. And to be blunt, I see a lot of implicit acceptance of risk in the AI community, right? We don't even try to map the risk. We just implicitly accept it and move on. And that's one of the main things that the AI RMF would try to correct in the market. Like we would want to map and then hopefully mitigate or transfer our risk. And if we make a decision to accept risk, it's an explicit, documented decision that's understood by management and the business, not simply sort of an implicit decision to accept risk without any thought about what the consequences might be. Okay, so these are the 4 functions. The 7 things we want from an AI system, the 4 ways that we do it. Okay, so, and this is all the core AI RMF document, this sort of core strategic policy level document. NIST AI 100-1. All right, now, there's something known as the Risk Management Playbook, which is mostly a website. If you're an extreme nerd like me, you can download the JSON file and play with it. It's available in an Excel spreadsheet. It's available as JSON, but it's mostly just a website. Okay, it's available as a PDF. But this is where we get into the lower level guidance. Which open source software packages might you think about applying? What should your policies look like? What section should a documentation template contain? What if I want to learn more about explainability? What if I want to learn more about meaningful transparency? What if I want to learn more about bias testing? The playbook is the place you go for that information, okay? And it's mostly just a website. But I hear I think people read the AIRMF, the core document, and they're like, well, it didn't say anything about data poisoning. I mean, I think technically it does have the word data poisoning in it, but the playbook is where you will find detailed information about what to do and where you can learn more about these types of risk. Okay, so this is some of the research that I was mentioning. So you don't build good guidance without doing good research, right? And so right now we are in the midst of very, very intense research around generative AI risk. But prior to that, we were researching things like explainability and interpretability. And again, I want to be clear, like, there are people in this room that we brought one of the first explainability products to market, and that's one of the best explainability papers I've ever read. Okay, the psychological foundations of explainability, interpretability, and artificial intelligence. And again, it really, a vector of Shapley values, right? A vector of numeric values in your Python script is one thing, okay? Having people actually understand an interface and understanding the cognitive processes by which that might happen is a whole nother level of transparency. And I'll go ahead and say that if you're in DC, if you're a DC person and you're into AI, you should know Professor Broniatowski. So Broniatowski is the PI, the principal investigator for the NSF Institute for Trustworthy AI in Law and Society. He's a systems engineer. He's been doing AI for a very long time. And can't say, if you have time to read this paper, I would read it. We also did research into managing bias in AI systems. And there's a lot of technical approaches, and there are renowned experts in this room at managing bias in AI systems, and I'm happy to introduce you to them. But what are some of the core things beyond the technical approaches for managing bias? Well, governance. Okay, governance is really important in managing bias. Talking to your users is really important in managing bias. And this is my favorite example, and it was it was the EEOC that very kindly pointed this out to me at one point. We can do all these bias tests, right? We can get scores from AI systems kind of balanced across different demographic groups. We can talk about how problematic that is in terms of actually measuring bias. Whatever we do on a technical level, right? We can balance scores across demographic groups and have those scores appear to be what we might call fair. Well, if someone with low vision or someone with problems with fine motor skills or any other potential disability sits down to use the system and they can't use it, it's not fair, okay? So we can't think about, fairness just in terms of scores from models, right? And that kind of just, if that happens in an employment application, then that's called screen out discrimination, and it's a legal problem, okay? So I got my hand slapped pretty hard on this paper by the EEOC, who pointed out, like, hey, you forgot about those with disabilities. And that example always sticks with me because it's true. You can balance the scores that come out of an AI system. We know how to do that. That doesn't solve fairness problems. It goes a long way, but it doesn't solve all fairness problems. And again, that's why we're so focused on AI systems in the world, okay? Their impacts in their world, their interactions with people and users and the public and impacted communities in the world. And we also worked on a big glossary. So these are some examples of the research that we've been up to support the AIRMF. There's a lot more coming, and there's a lot more coming for generative AI. Okay, and so this is kind of about the future. This is a long-term project, right? The AIRMF is going to be a decades-long project, right? There's the cybersecurity framework, there's the privacy framework, and the AI risk management framework sort of follows in their footsteps. These are all very long-term projects. But people oftentimes ask how they can get involved, and we're going to talk about more ways in just a second. But one of the one of the most useful ways to get involved is to write a profile. And that might sound difficult, especially since some of you might not have that much familiarity with the framework. But essentially what that means is you write a document that says how you would apply the AI RMF within your sector or within your organization. And so I always tell clients and friends and colleagues that if you really want to dig into the RMF and really understand it, write a profile. And if you do a good job, NIST will be happy to publish it on their website. Again, I can't promise that, but we are seeking profiles, right? We are seeking high-quality profiles of people explaining how they applied the AI RMF in their organization or in their vertical, okay? Because the AI RMF is vertical agnostic. It's not for banking. It's not for military. It's for everybody, okay? And a profile is a good way to get involved. It's when you write a document discussing how you would use the AI-RMF in your organization or in your vertical. And we have sort of like vertical specific ideas for profiles, say in insurance, and we're internally on the AI-RMF team, we're working on a horizontal profile on generative AI. Okay, so the next steps are all about generative AI. Last fall, there was something known as the Generative AI Public Working Group, GAIPWG. It's done now, okay? This one's done. But we took public comment from thousands of participants across industry, academia, government, on Slack. It's a big, crazy Slack channel, or several big, crazy Slack channels. And we were taking public comment on 4 main topics. So our main focus with generative AI is content provenance, watermarking, making sure that people understand when content is generated by AI systems, governance, of course, instant disclosure. We need to share information about failures in these systems. And that's a whole different topic that we could spend an hour on. But we want to share information so we don't repeat failures. That's the basic idea. We don't share information about failures to name and shame. We share information about failures to prevent future failures. And then pre-deployment testing. So I'll pause on this one for a minute. I was really confused why would NIST need to take all this time with pre-deployment testing? Of course, you would always test a stochastic statistical machine learning system. You'd always test that before you deploy it, right? Right? Yeah, turns out not. And it turns out, especially for generative AI, people are deploying these systems without validating them. Perhaps giant tech companies are, deploying giant, super famous generative AI systems without really validating them. Just maybe. Okay, so what comes out of all this public comment activity is that horizontal generative AI profile. So within NIST, we're taking, we took all this public comment from thousands of people, we divided it up into these 4 buckets, and we'll be writing the horizontal profile, vertical agnostic, industry agnostic profile for generative AI, and that's coming, I guess as fast as we can type it. What's coming next is what's known as the U.S. AI Safety Institute, and some of you may be members of the U.S. AI Safety Institute. Congratulations. And if you're a member, then you would be a member of the consortium. And that's I think there's about 200 members so far, again, across academia, industry, and civil society. These are universities, these are big companies, these are small companies, these are charitable organizations, and the idea is to enable NIST to, again, work with the public, work with industry, work with academia to build the best possible guidance. And the focus in the Safety Institute, at least initially, will be risk management, generating synthetic content, capability evaluation, what can these systems do, red teaming, how do we test them in an adversarial manner, and safety and security. Then, of course, there's the AI executive order, the recent AI executive order in November, which had a big, long to-do list for NIST. There's a lot that NIST needs to do under that executive order. Some of the things that you see on the screen are included, but one of the main new deliverables, and Riva talked about this earlier, is the Generative AI Testing, Evaluation, Validation, and Verification, TEV. The GAI TEV guidance will be coming out, and that's ostensibly due in the summer under the new executive order. So I see we have just a tiny bit of time left, maybe one or two questions, but that's your basic rundown of the NIST AI RMF.
Ooh, there we go. Patrick, these are really fantastic presentation, and you have quite a few interesting, in some cases, philosophical questions. Okay. We'll probably, because of time, we'll probably only do two, but okay. The first one is, don't frameworks like NIST AI RMF just introduce overhead and slow innovation when engineers should be trusted to do the right thing?
I can't answer that honestly in public. No, that's an absurd sort of conjecture, in my opinion. Engineers aren't special. Nobody's special. Lawyers aren't special. Engineers aren't special. Bankers aren't special. We all have to work together. We all have to be humble in the face of this very powerful technology that we are invoking and work together to keep it safe. Engineers aren't special. Sorry. Next question.
All right. Let's see here. So, earlier, a presenter said you had a database on AI real issues that happened.
Yes.
Is that database public?
Yes.
And what part of the RMF would have stopped the issue?
Again, it's hard for me to. So this is the AI Incident Database. You know, I do way too many things. I'm the chairman of the volunteer board that runs the AI Incident Database. We've cataloged about 600 incidents, over 600 incidents of failures in AI systems. Again, the object is not to name and shame. The object is to share information so we do not repeat failures. Airplanes used to fly into mountains over and over and over again, okay, until we learn from each other how not to do that. So the idea here is don't fly into the mountain over and over and over again. So the AI Incident Database is a public resource. It's a California nonprofit. Right now we're funded mostly by UL, Underwriters Laboratory, that has a 129-year history in consumer safety. And check it out. It's a great resource. Before you're designing an AI system, you should look at failures and not repeat them.
All right, and great. And one more. How can an organization become a member of the AI Safety Institute?
It's too late now. It's too late for the first round. There was a public sort of announcement probably right on the heels of the AI executive order, and you had to apply by, I think, January 15th. So it's too late for the first round, but as I said, this is a long-term effort. Let me see if I can I'll pull up really quick. I don't want to go over time. I know I'm already over. And I'm happy to share these slides, but this is the website. And there's always multiple emails and different forms and that kind of thing for contacting NIST about being a member and getting more information on it. Membership, I believe, is closed now. There was a January 15th deadline, but this is a long-term effort, and I'm sure there will be more opportunities.
All right, thank you, Patrick. Let's give a big round of applause for a very complex but very important topic, especially in this field.
Thank you very much. Oops.
Okay. All right, how you all feeling now?